actually have a question.
Yeah.
So in 1.2, or when we did the cumulative stuff earlier today, we did percentages. In the book, I saw that it was asking us to do decimals and add them up to 1.0. Is that going to be okay?
That's fine.
Okay.
Either way is fine.
Okay,
Yeah,
thank you.
yeah. This percentages just make more immediate sense to humans. So I normally go to percentages, but they're the same number. Yeah. Yeah.
I said no if I had to redo the.
Oh no. All right, guys. So getting right back into it. I think 20 minutes is a pretty good time because that gave me enough time to start the first part of the lecture upload. So that's awesome. So that's all right. Yay. So right off of what we just did. So if on a quiz I say find the 5-number summary, you have to remember that's what it is. And again, the way I look at it, and if you're not a sports fan, you still know about sports. It's like the beginning of the game, first quarter, second quarter, third quarter, end of the game. Right? So it's kind of a nice way to remember it. Okay. The immediate picture we can make is called the book calls it a box plot. And again, that's not the real name. The name is a box and whisker plot. Okay. So the box and whisker plot is created straight from the 5-number summary. And I got a handout here in a minute that's going to show you the real purpose of the box plot, box and whisker. So what I want to do, any scale you make in mathematics has to be consistent. So I'm not going to do this. This is wrong. 61, 67, 70, 73, 79. I always get somebody who does this, and I do this. 6, 3, So the scale's got to be consistent. So the only thing my data tells me is roughly where I should start and roughly where I should end. So to me, I'm going to start at 60, right? And then I'm going to go up to 80. So 60, 65, 70, 75, 80. Beautiful. So I just want my scale to be independent to the point of it's got its own, its own tick mark length. But I got to make sure all my data fits within. So here's what I'm going to do. It's a little different than algebra. I'm not going to put a point. I'm going to put a line above 61. I'm going to put a line above each of these. 67, there, 70, 73, 79. Put a line. Kind of scruffy looking, but oh well. The middle 3 makes the box. And then these are the whiskers. Has anyone ever seen a picture like that?
Yes.
Yes? Okay.
Can you pull it down a little so I can see what's up there? Oh.
That's all that's up there. It's just that picture. Yeah. Let me take all this other crap out from behind. There we go.
The whisper plot.
Box and whisker, yeah. Okay. So from this, does it look symmetric?
No.
Well, let's see. A non-symmetrical box and whisker would be something like this, maybe. Is that symmetric? Nope. All right, so this definitely looks symmetric, which kind of makes sense because I think this is the data we plotted and it looked roughly normal, right? So the symmetry in the box plot makes sense. Can anyone tell me what percentage of the data is in the box? What's in the box? There you go.
Is it 60%?
Nope.
80.
50%.
Lower.
7?
7?
Yeah.
I like it. No, but I like. Yeah, the reference was 7.
Yeah, there it is.
But it wasn't 7%. That would have been funny if it was 7%. What does this line here mean again? What's that line right there?
25, 65.
Q1. What percent is below that then? What is this percent right there?
That's
25%. That's what Q1 means, correct? What is this line? What's this line? What percent is below this line? 75%. So what's in the box? 75 minus 25. Yes. Is everybody cool with that? It's just a nice visual. It's beautiful physical idea. There's 75% below this. There's 25% below this. So there's 25 minus 75, 50% in the box. So every box plot you ever see, that's what they call the heart of the data, the 50%. There's if you're considering what college to go to, there's a book, the Princeton Review of Colleges and Universities, whatever the shit. They always give the middle 50% GPAs, the middle 50% SATs, just to show you a quick way to compare colleges. What's the heart of the student's academics look like? So at an upper scale school, it'll be higher than at some other school, right? Okay, we all know GPAs. Well, I worked 3 jobs through college, so I like to say that my report cards often had personality. Is the way it wasn't it was okay. Yes.
So is that the case for even like the uneven box plots, like the box that'll always be 50%?
Totally. I don't care where that box is, it'll always be 50% in there. I love it. So this one, what is this most likely then? Where's most of the data? Isn't most of the data down here? Isn't this 75% of the data? So this is most likely a what? Or let me say it like this, an outlier. I don't know if anybody ever saw Children of the Corn. I was thinking, Outlander. Okay. That would be an outlier, more than likely. So let's make that more specific. So is everybody relatively, is the 5-number summary a terribly difficult thing to calculate? If you forgot how to calculate it and I ask you to make a box plot, could you just get the numbers from your calculator so you could do the next part of the problem and make the box plot? Do you guys understand? So if you're like, oh shit, I forgot how to calculate this, but I remember how to do it in the calculator, and then I can make a box plot so you're not going to lose points on the frickin' box plot. Do you guys understand? So there's one level of understanding I want you to be able to calculate these things, and the next level is I want you to be able to draw the representation of those things. Those are 2 possibly separate things. Okay, maybe. It always kills me when people leave things blank that you really didn't need to, because I know you can probably do it. Okay. Let me do this. Let me give you this. I don't actually want to do number 1, just in the interest of time, because I think we've already done enough examples of that. I want to look at number 2, the one about golf. Anybody here play any golf? Yes?
Yep.
Are you pretty good?
Could
Good enough? Okay.
Like mini golf.
There you go. I was waiting for somebody to say that. Let's see here. Real quick, the first time I played mini golf, I was like 8 or something, and I had no idea what I was doing. So I hit that ball, and it went flying over the fence across the street. And I went inside with my mom or whatever, and she said, "Oh yeah, you hit the ball too hard." And the person was so mean to me. I'm like, I have no idea what I'm doing. Anyway, sorry. Little traumatic experience I had to go through. It's like an 8-year-old, yeah. And they're like, "No, what are you doing? What are you doing?" I'm like, "Help!" Yeah. Oh, some people just need to get their aggression out on an 8-year-old. I don't know. So let's not worry about this first problem. I think we did. Well, maybe not, but we'll see. I want you to look at problem number 2. Okay. I want you to read through it. I want you to notice how both of these box plots use the same scale, correct? So you can read both of them. And I want you to try to answer. I will tell you this, if you read through, I do tell you they hit 200 golf balls, yes? Okay, that will help you with part A. Oh yeah, shoot, I always forget. Yeah, just do part A for right now, because now I gotta come in with part B. So part A is a 2-step problem, right? So you got to look at the Callaway golf balls. So these guys. What can you tell from the box plot in relation to 252?
25% of.
Yeah, go ahead.
Less than 252 yards.
What's less than 252?
Uh,
Oh, yeah, a quarter. So 25%, like you said. So 252 is the first quartile, correct? Minimum Q1, Q2, Q3, high. That's the first quartile, 25% or below that. So to figure out how many golf balls went less than 252 yards, I just have to take 25% of, or 1/4 of 200. 200 golf balls, yeah.
So 200 divided by 25%?
200 divided by 4, or 200 times 0.25. Yeah. So it's either 0.25 times 200 or 1/4 of 200 because they're both the same thing.
50?
50. So 50 Callaway golf balls went less than 252 yards. Okay, and I constantly do this. I think I partially want to just shut up for a minute and then I give you something too quick. The thing that's called the IQR, that stands for interquartile range. Oh, there. And what I should have said before this, which we haven't got there in the book yet, but I often like to say this before I get here, is that in any data, there's something called the range. And all the ranges, what really makes sense, if I had people from ages 10 to 30, how wide do the ages range? 20. So the range is just high minus low. Is that cool? The range is just the highest minus the lowest. It's how far your data ranges. Let that make immediate sense. Interquartile range then would be one step in. So not high minus low, but Q3 minus Q1.
So low minus high?
No, not backwards. So not high minus low, but Q3 minus Q1. Interquartile, the two quartiles that are one step in. Q3 minus Q1. So for the Nike data, what is Q3? 266. And what's Q1? 250. Oh, Penn, what are you doing? So what is the IQR? 266 minus 250? 16. All IQR is visually is how long is the box. Right? Not like what's in the box, but now we just want to know how long is the box. How you guys doing? So again, it kind of makes more sense to me if you know what the range is, high minus low, interquartile is one step in, Q3 minus Q1 instead of high minus low. What we're trying to get to is a more technical way of identifying what an outlier is. Go ahead, sorry.
Isn't Q1 245 and Q3 is 255.5?
No, remember it always goes minimum. Q1, Q2, Q3 maximum. So this is the min. This is Q1, Q2, Q3 max. Okay, you guys with me? What's up?
I'm so lost, I don't even know what to ask.
Understood. All right, just looking at this picture, right? Just this picture. What's Q2? Just looking at this picture, what's Q2? What's the 5-number summary?
268.5?
Yeah, so this would be the lowest, right? That's the minimum. And then Q1, Q2, Q3, maximum, right? Is that cool? So that's just the 5-number summary, just put visually. The definition of what we call the IQR, the interquartile range. The definition of that is just Q3 minus Q1.
Q also be known as the median?
We're getting there.
Got it.
Yeah, that's the next section. Yeah. Okay. Yes.
What's the 1.5?
Oh, we're getting there. Okay. I love you guys. All right. That actually that warms my heart. So don't hold back on any questions. I love it. So for Nike, the interquartile range was 266 because that's Q3 minus 250 because that's Q1. So 16. So the official definition of outlier. So we kind of intuitively know an outlier is just far away from where most of the data is. So we're going to try. So doesn't the box kind of represent where a good chunk is? Half of the data is in the box, correct? So it sort of makes sense that outliers, I should define them to be if they're a certain distance away from the edges of the box. Does that make any sense? Most of the data, half of the data is in that box. So if I get far enough away from the box, I'm an outlier. So if half of the heights are between 5'4" and 6'2", and you're 7'7", you're a freaking outlier. Yes? Nothing's wrong with you. Nothing. You're just not something we normally would see. Oh, hey, right. Okay. So if I calculate the min and max expected, so that means where unusual starts. So wouldn't you say that somebody who is 4'1", wouldn't you say that their height is unusual?
Yes.
And that's not a derogatory thing. It's just not what we usually see. That's all unusual means. So it kind of makes sense. The expected values, anything outside of there would be unusual. Okay, I like it.
Like an albino alligator.
Exactly. Yeah. I'll show you the equation for that later. So Q1 for Nike was 250, right? Minus 1.5 times 16. So minus 1.5 times the IQR. So if I start at the lower edge of the box and I'll go down 1.5 steps, 1.5 IQRs. That'll be where unusual starts there. So let's see. So the minimum value would be 250 minus 24, right? 1.5, 16 is 24. So that'll be 226. So double check me on that. Is that okay? 1.5 times 16 is 24? Okay. And the max will be 250 plus 24, which will be 274. So can somebody tell me, I'm sorry, it did 250. That's my fault. Good job, Jeff. Should be 266, right? That's my fault. Should be Q3, the other edge of the box, plus 24. So that is 290. 266, poor little dude. So would 287 yards be an outlier officially? Nope, it's not further away from there than these. How is it close to being an outlier?
Yes.
Yeah, it's pretty close. Okay. So for that Nike golf ball, if I had this person hit the ball and it was less than 226 or more than 290, that would be unusual. Yes.
So outliers have to exist outside of both the min and the max?
Yes.
Okay.
Yes, the min and the max expected, that kind of like bookends where I expect things to happen. Anything outside of there would then be unusual. It's sort of like I expect somebody to be more than 5 foot and less than 7 foot. So if I see something outside of that, yeah.
Okay. I thought it wasn't possible to go outside of the min and max, so I thought quartile.
Oh no, but it's the min and max expected values. Yeah.
That makes sense.
Why are we using 16 again?
Oh, because the IQR is just 16. That's what it is. IQR is Q3 minus Q1. I like it. Okay. So again, you all came into this class knowing what an outlier means. You intuitively knew what an outlier meant. I'm almost certain. This is our first more concrete definition of identifying outliers. A huge part of statistics is actually identifying outliers. Because, for example, if I work in a nuclear power plant and I see the little needle going from green to yellow. I'm like, it's starting to become an outlier, and that, oh shit. Okay, I wouldn't wait. The minute it starts going towards the yellow, I'd be up, right? Stop eating my donut and just get to work. All right. So here's a judgment call. Which golf ball would you choose to use? Would anyone choose the Callaway?
I think it'd be more fun to use Callaway.
Why?
Because you could hit it theoretically. The gap for from Nike's ceiling to its ceiling
Yeah.
is bigger than the gap from Callaway's base to Nike's base.
Yes. Okay. That's not necessarily the right answer because this is a subjective question. Does anyone want the Nike? I'm sorry, is that the one? No, Nike. Anybody want the Nike? You wanted the Nike. Anybody want the Callaway? Nike? Nike is, do you agree with me? Nike is more predictable.
Yeah.
Right?
System.
But if you're a gambler, which one would you want to take?
Callaway.
Because you do have a chance, yes, to hit it a lot further. You actually have a chance to also not hit it very far. But and real quick, notice this: isn't 75% of the Nike less than 266 yards? Isn't 50% of the Callaway more than 268.5? Because so there is no right answer to that part C. There isn't a right answer. It just is a question to make sure, can you interpret what you're looking at and then use your own, how much do I want to gamble, how much do I want consistency, to figure out what the answer is for you. Yeah.
Based on the box and whisker plots, 50% of the balls you hit from Callaway are going to be in Nike's 25th or 25% range for its max.
Yeah, this almost fits in here. So
Yeah. So wouldn't Callaway be, because so much of Callaway's box whisker is above Nike's like top
Yes.
performance? Wouldn't that mathematically be the best choice then?
There's no mathematically best choice.
Okay.
Because again, if you don't feel like risking this,
Well, but I'm just talking about like, I guess I'm not an odds guy, but wouldn't the odd? I mean, I like gambling, but I mean I'm not proficient with the odds. But wouldn't your odds be that more than likely the balls you hit for Callaway are going to be greater than the balls you hit for Nike?
that was the point I was just sort of trying to make. But again,
Okay.
it's a question of how much are you scared of losses and how much are you hopeful for gains, right? It's a gambler thing. So I don't want to get that deep into it, but I do understand where you're coming from.
Okay.
And you're right, but it's a little more than that.
Okay.
Okay, that's all I wanted to show you was the reason we make box and whisker plots, the primary reason is because I can then stack several different things and kind of compare them. So I stack several different colleges and I can compare their stuff and so forth. Okay, I like it, maybe. So box and whisker, I'm hoping is not that horrible. 5-number summary, percentiles aren't that horrible. 5-number summary, you get them from percentiles, also called quartiles, and then you just draw the lines to make the box plot, is my hope, right? And you're all like, well, yeah, you say it like that, it sounds great. Okay, all right, so let's get into what I think you all expected to happen immediately in a stats class. Statistics? Oh, poor little dude. Here, take a break. There you go, buddy. Okay. Oh no, okay, that'll work. Poor little camera, I think you're a little drunk. Okay, there you go. So, what I mean by that, oh, by the way, if you didn't notice, make sure you guys understand. Who is 1 is tomorrow? Definition, stem and leaf. It's basically 1, 1, 1, 2, and 2, 1. And then quiz 2 is next Tuesday. What's happening next Monday? Holiday. Juneteenth, holiday. Tuesday we have quiz 2. Histograms and percentiles. Then we have a test when? Thursday, I love it. So on Tuesday, maybe even before that, maybe tomorrow, we'll see. I'll have a practice test, and then on Wednesday, I'll have the answer key for the practice test. So the day before a test will include review with an answer key for the practice test you will have gotten before. Yeah.
So what sections are quiz 1 and quiz 2?
Let's see. This will be 1-1, 1-2, and 2-1. This will be and 1-3 a bit, but just the definitions, right? And this will be 1-3 because it's got the frequency tables. 2-2, 2-3, and 2-4. Yay. Okay. So again, that's Tuesday. You got time to do that homework. If you send me an email with questions, I can't guarantee I'll get back to you really quick over a weekend, but I will get back to you. And I'll do my best I can. It's not easy to tutor over email, but I do what I can. Okay. Let me make sure that gets on video. There it is. Okay. So, one thing I think you might have thought the minute we got into a stats class, when I say statistics, you say statistics, like what immediately comes to mind? I think I asked you this question the first day, but like mathematically, what do you expect to be kind of churning out?
Percentiles.
Maybe percentages, averages, right? Right? What we also call what we call an average now? Mean. So what we have is we have ideas of where the center of data is. And believe it or not, there's more than one. But the immediate one we all think of when I say where's the middle of the data, well, it could actually be two different things you would think of. But one thing we think of is the mean, which is another name for the average, of course. This is going to be where we get our first little taste of what a formula looks like in statistics. So be ready. Can somebody please tell me, given a set of data, how do I calculate the mean?
I don't know, divide by how big all this are.
I love it. So I'll put it down in English. So in English, to calculate the mean, add all up, divided by how many there are. I guess this is pseudo-English, but that's now math people, we don't all write as poorly as I do, but all of us don't like writing too much. We like to be really, really succinct. So part of mathematics for a student is getting caught up on the shorthand weird shit that we've decided through history to use. So this isn't that weird. The official name for addition, what's the official name for addition? It's a very short word. Sum, right? Sum things up. Not something, but some things up. Okay. So add all up. Add we use the symbol, the Greek letter S, which just looks like a very serious E. So this is the Greek letter sigma, Greek letter S. So that's math people going, well, sum starts with S. Let's use Greek. All right, which is effectively the drunk history of math. But so add them all. Now, help me out. If I had a list of data, they are all answers to a question, correct? And what was the question called? What do we call that in statistics? What's related to the question? So the data is the answers, variable is the question, right? So here's where the kind of algebra comes in a little bit. I'm going to call these x. They are all the values for x, correct? My question is my variable, x. The answers are the values that can take on. So add all up. The would be all the x's. So this means sum up the x's. Okay, we're going to talk about this symbol here in a minute. I'm going to kind of blow it up a little more to really, because we're going to see this symbol the whole semester, right? And it's, whatever it's a part of will tell me what I need to get. So I'll show you in a minute. And then down here, how many there are. That's the number of data points. So what letter should I use for the number of data points? I love it. I just wanted somebody to go P. No, so N. That's our first little formula. And you can see, I really want you to understand what formulas do. They just say something very quickly. So in English, here's in English, and here's in Mathish, right? Okay, so I'm pretty sure you all understand. Math is a foreign language. The first hurdle is learning the terminology of that new foreign language. And then PEMDAS is like the grammar. And if anybody's ever learned English from knowing another language first, the grammar's insane in English compared to other languages. Okay. The symbol we use for the mean depends on if it's a sample or a population. So for a population, we use the symbol mu. We've seen that before. So that's the Greek letter mu. So that's the population. And for a sample, we use the symbol x bar. Both have the same formula, which is kind of silly. I think the book puts a capital N for population, but the book's insane. Yes?
Are they also mean and average?
Yeah, mean is just another name for average.
But the mu and the x bar is also like mean.
Those are both averages. If I see the letter mu, it's a population they're talking about. If I see the letter x, the symbol x bar, it's a sample they're talking about. I like it. And in statistics, it's incredibly important to know if I have a sample or I have a population, because if I have the population, I'm like, holy shit, because we don't normally have that. So real quick, if this is my data, let me put it like this. If my data is this, what is, so let's see, example. My data is this, what is this? That's my data. What is this? So what is it? Not in words, in mathish. In the numbers. What's the number?
1 plus 1 plus 7 plus 9.
Total. So what is it? 23. So Jim Carrey would freak out, but that's all right. Amazing. What if I ask you what this is? Is that 23 squared?
No.
Shit, no. What would 23 squared be? This. No, that's double. Be careful. This would mean square the sum. Yes? That's what that would mean. That would be 23 squared, which is something or other. What the hell does this mean? If you cover up the summation symbol, you need a bunch of those before I can add them up. This says add up these. Do we have these?
No.
Do we have the x squares? No. Can we get them really quick? What's x squared? 1, 16,
49, 121.
121, kick ass. What's the sum of those? 187. I love it. Do you guys start to understand it? We're going to see formulas. It's going to have a summation symbol with some shit next to it. If I cover the sum, I go, oh, I need a bunch of those. I need a bunch of those. If I can make those, I can add them up and I can stick it in the formula, right?
So, if you were to put the parentheses in EX squared, it would go around the sigma x, right? Because it's sigma x is representative of.
Yeah, this means 23,
Oh, I didn't see
and then
that.
it was squared.
Oh,
Yeah,
okay.
whereas
Sorry.
this means add up the x squares.
Okay,
Yeah.
right, so I didn't see the.
You're good, you're good. You okay out there? So what if I said this? What if I want to know the sum of x minus 1? What would I have to get a list of? No, 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 no.
Oh, would you just take out?
Do I have a bunch of x minus 1s? I have a bunch of x's that have a bunch of x squares. Do I have a bunch of x minus 1s yet?
No.
So I have to make a column that matches what this thing needs. So what's x minus 1? 0, 3, x minus 1, 6, 10. What does that have to be? 19. Do you guys start to understand? The thing that is next to this E, that's why I say cover that up and go, oh, I need a bunch of those. So you have to make a column for those, and then I can add them up. That is going to happen so often in this class, I want to make a big deal of it right now. Maybe. How you guys feeling? You guys all right? So we're going to do a decent amount of table creation in this class. And we're creating all the shit that my formula says it needs, right? And we're also going to create the formula, so it's going to be exciting. Okay. I'm going to erase all this. So we'll get more and more practice with that as it comes up. Okay. So the mean, I took something as easy as the average and I made it really complicated. So that's exactly what a math teacher can do. But hopefully you understand this is just getting ready for later. This is what the mean is. This is our first real formula here. So it's either mu equals that or x bar equals that. Either way. Population, sample. This word came up earlier. If I just gave us a list of data and I said what number is in the center? What else makes sense? What number is right in the middle?
Average.
We got that. But real quick. 1, 2, 3, 500. In fact, let me do 1, 2, 3, 4, 500. What number is in the middle? Is that the average? Shit, no. It's the median. I love it. So there is another thing called the median. Its symbol, it looks like a sample mean that had a rough night. Its little hat got all bent. Poor little dude. So that's the symbol for median. All the median is, as somebody pointed out earlier, is P50. It's the number in the middle, which is the 50th percentile. Does that make sense? It's just another name for Q2, P50. But there is a bit of a shortcut to find the median. If I have an odd number of numbers, then I can always find the middle number, yes? So watch this. There's a little bit of a shortcut for finding the median. If I take the number of things I have, and I add 1 and divide by 2. So if I had 5 numbers, what's the middle? The third one, yes?
Yeah.
What's 5 plus 1?
6.
Divided by 2?
3.
3. All right, sweet. You with me? Now what's 4 plus 1?
5.
Divided by 2?
2.5.
2.5. The 2.5 number, meaning the number between the second and third. So that's a bit of a shortcut to find the median, yes?
But why would you need to do that if an odd number if you could just find the
Well, if I have 87 numbers, no, I'd much rather just do the math and then get it, right? Okay, I appreciate that. If I have 5, screw it, I can see it. You don't have to use this. You could actually just figure out P50 to figure out the median if you want to do it that way. Take 50% of the number, round it up if it's all that kind of stuff. It's up to you. Okay. So the median, why does the name make sense? Because what's right in the middle of a road? All right, so it's the thing that's right in the middle. Okay. Why are there situations, and I've got one right there, where I don't want to use the mean, I'd rather use the median? Let's say this. Let's say I have a company. I'm about to start work at a company. And there's, let's say, 3 employees who make $30,000 a year, $38,000, $42,000, and then there's a CEO that makes $600,000. Is everybody with me? If I ask them, how much money could I expect to make once I start working there, and they tell me the average, is that an accurate representation of what I expect to make there? No, right? If instead they tell me the median, what's the median?
40.
It's right in the middle of the 2 in the middle, yeah? So it's just 40,000. You guys with me? 40,000. Is everybody all right? So the median is right in the middle. So there's 2 in the middle, so it's right in the middle of the 2 in the middle. What's the middle thing? The middle of the 2 in the middle. That's so damn middle, it's crazy, right? Okay. So the median of this would be 40,000. So again, let me put some stuff over here. Let's look at some examples real quick. Okay. So some simpler little examples. If I have a set of data like 1, 3, 9, 11, 12, what's the median? 9. Why is 9 the median? Because it's in the middle. Also, more importantly, almost, is the data is in order. Right? If the data didn't need to be in order, I can make the median anything I want it to be, which would be line. So is everybody cool with the median on this problem is totally 9. It's right in the middle. Okay, I love it. What about the median of this data here? Yeah, there's no number in the middle, is there? Because there's 4 data points. So the number that's in the middle must be in the middle of the 2 that's in the middle. That is so freaking middle. So what's in the middle of everything? 6. That's all we're doing, right? So over here, it does, so the median does not give the first shit what the numbers are. It just says, what's in the middle? So if I made that number 600 billion, right, 600 billion, the median would still be 40, yes? The median just cares what's in the middle. 40's in the middle. How are we doing? Maybe? So the middle number, if there's an odd number of numbers, there will be a middle number sitting there for you. If there's an even number of numbers, you have to average the 2 in the middle. Which kind of feels like it kind of goes with percentile. Isn't there 2 things we do for percentiles? That jives right with those 2 things we do. Okay. So in this example, what's the average of these, by the way? What's the average of those? What is it?
177.
Yeah, okay. $177.5 thousand. So if I said, what can I expect to make when I start working there? And they said $177,500 a month. No, a year. And I'm like, whoa, holy shit, yeah. Well, they lied to me. They took the average, but that's not really representative of the center of the data because I had, what would this be called? This is definitely an outlier. So anytime our data has outliers, we'd much rather use median. We live in San Diego County. Anybody ever went to La Jolla?
Yeah.
What is it about La Jolla that I want to, especially, that I want to report median instead of mean? Walk around and you look and I'm like, oh, there's another place I'll never be invited to. All right, yeah. No.
Old money?
Huh?
Old money?
Houses. House prices, yes? Whenever you see a report about the state of home prices, they will always say median home price. Of course they will. Because how many freaking outliers are there in especially La Jolla? A lot! You know, and then there's some reasonably priced places, but there's quite a few that are like stupid. Yes? You guys with me? So of course they're going to say median. Another place would be obviously income. They're going to say median income because it's more representative of the middle of the data because it has outliers. So this, again, that's why we don't stop here. When I say what's a measure of the center of the data, I don't just stop at mean because sometimes the median is better. That's why I have both ways. How are we all feeling? Is that okay? Okay. All right, so the median, it could either it is the number in the middle, if I have an odd number, or it's the average of the 2 in the middle. Now real quick, let me see if you guys are paying attention. What's the median of this set of data here? What were you going to do, Jeff? I forgot. Oh, yeah, okay. What's the median?
2? Oh, 8.
It's definitely not 2. I'll tell you that right now.
8.
So what's the first thing you have to make sure? Your data has to be in order. Yeah. Otherwise, you can make the freaking median anything you want. So what's the median? 8. I like it. Does that make sense? If it doesn't have to be in order, then what the hell does median mean? It means nothing. I can just go, let me put that there. There you go. You know, it's like, no. Okay, maybe. Okay. So median is relatively simple. And just to show you with this again, I have 4 data points. 4 plus 1 is 5 divided by 2 is 2.5. So it's the middle of the second and third. You don't have to use that. I just want to show it to you because it's out there. But you don't have to do that. If it's a small set of data, you definitely don't need to do that. Okay. there is another measure of center. There's actually two more. One of them I'll show you, but it's not that big of a deal. What kind of data works with mean and median? So what's the two main types of data, the big two? Starts with the letter Q.
Quantitative.
Quantitative? Qualitative. Do either of these work with qualitative data? Shit, no. And again, that's when I asked you, can you average the type of car that I see in the parking lot? What's BMW plus Ford? I don't know. Right? So another form of the measure of center is called the mode, and this is the only one that works with qualitative data. Mode, the way, this is not the way I remember, but anybody heard of pie a la mode? What does pie a la mode mean? Pie with ice cream. So, I'm like, so when I get pie a la mode, I'm like, I want the one with the most freaking ice cream. Okay. So mode means most. It's just the thing that occurs the most. So if I go in the parking lot and I see 12 Fords, 7 Chevys, and 20 Hyundais, what's the modal type of car? What's the mode? Hyundai. It's the one that occurred the most. So there, it works with non-numerical data. Whatever occurs the most, that's the mode. It will work with numerical data, of course, also. So here's an example. So what if I have this? What's the mode here? Incredibly enough. Holy shit, it's 3, yeah. So whatever occurs the most. So what's the mode of this data?
Nothing.
No mode. Nothing occurs the most. Once, nobody wins. Right? What about this data here?
You say 2 and 3 are tied first.
They're tied. So it's bimodal. 2 and 3. So we go up to trimodal, and then after that we go, I'm trying to get a feel for where the center is. So this is a very numerical way to do it. This is a positional way to do it. This is a way to do it in terms of what's the most, right? And that works with non-numerical data. But now I'm kind of saying, okay, there's a couple places where it clusters. If it's more than 3 places, screw it. It doesn't have a mode. It doesn't seem to be clustering anywhere. What about this last one of these? 1, 1, 2, 2, 3, 3, 4, 4, 4. Okay, what's the mode?
4.
Obviously 4. I have a clear winner. There's no ties. The mode there is 4. And there is there's no symbol for mode. I think one semester we made one up just because poor little mode got left out. So I think we used capital M, but it doesn't matter. There's no real symbol for mode. Poor little dude. Okay. There is one more measure of center, and I'll put it up here, but it's not really, I don't think the book even talks about it, but I'm going to put it up here. And it's called the mid-range. Somebody remind me what range was.
Minimum, maximum.
Yeah, high minus low. Just how far does your data range? Mid-range is the number that's in the middle of the high and the low. So, for example, if I have this. Okay. How do you figure out the number that's in the middle of the high and the low? Oh, I see, it's sort of, but a more direct way is to take the average. To find the middle of any two numbers, you average them. So you would do 20 plus 4 divided by 2. What do you get? 24 divided by 2, 12. That's the mid-range. That's the number that's in the middle of the extremes. Guys, doing okay? You guys don't like that one. So the range is high minus low. Mid-range is the middle of those two. So the formula for mid-range is high plus low divided by 2. You average those two together. Now real quick, I think this is what you were saying. How far is 12 away from the lowest number? How far is 12 away from the highest number? So it's right in the freaking middle. Yes, okay. Now, will the mid-range always be the median? Shit, no. Hell no. So be careful, right? This one that just happened to be. Okay. I think I've almost got you to your edge of able to roll with what I'm putting out there. It's too bad for you. I'm gonna do a little. Let's see. I can't do all of that, can I? I could. Well, this is the next thing to do. So, these are all measures of sound. Let me do this. Okay, we're not gonna do this hand. We'll do this next time. Everything we just discussed were ways, if I have a set of data, how do I tell what the middle is? And they're all valid, but different ways to tell what the middle is. The one that we use is the average. It's the one we use the most often, but we did discuss why the median might work better. So, right? Okay. So, have you guys, I know you guys know about a website called Rate My Professor. Have you ever seen that?
Yeah.
There's another website. I'm not going to tell you what it is. You can actually get the grade distribution that teachers have given over every course they've ever taught. It costs a little money to get it, but it's, to be honest, you actually could call the school and get it. It's just free. It's just information that we have to give to people. So if you call the school and said, I want Waller's grade distributions for every stats course ever taught, right? And they're like, what? No, this is free public information. Just give it. But a website collects it, and then they charge you money to do it because they did the work. So let's say you look on Rate My Professor, and these two professors that have the same time for the class, they got pretty much the exact same ratings. Everybody with me? And you pay money, and you see on this website that they both gave an average of a C. So far, it's like a coin flip, which one to take. Yes? But then you look further, and you notice one teacher gave from A to F, and the other teacher gives from B to D. And one more piece of information. This is at university. Yes? What's passing here? What's passing at university? D. You guys know that? Okay. So remember that when you drive across the bridge, you're like, did this engineer make a D or shit? Okay. So you're at university. So one teacher gives A through F, one teacher gives B through D. So that is not a measure of center, that's a measure of spread. Yes? So when I have data, I want to know where the middle is, and I want to know how spread out the data is. If I had those two pieces of information, I don't have to see every damn data point. I can kind of have a quick idea of what the data sort of looks like. Are you guys at all with me? So, let me ask you this. Which teacher would you take?
The second did it.
All right, so you say A through F. Why do you say that?
It's more likely to get a B or C, and it means that the spread is wider, so there's more.
Okay. All right, I see what you're trying to say, but not necessarily. But I appreciate what you're trying to say, yes.
So you said that's at university, so D's passing.
Yes.
And if the second professor gives D through B, even if you're on the low end of that distribution, you should pass and get your degree anyway.
Okay, so one way to look at it is, I want to be sure I pass. It seems this other professor never gives an F, so I'm guaranteed to pass.
It's unlikely. It's much less likely than the first.
No, I said B to D. Never has given an F in this
yeah,
entire
yeah.
time. Yeah. Anybody would take the A through F? I'll tell you this. I took a class with a guy who never gave A's. And I had no choice, but I had to take it. So sure enough, I got my B. I got the highest grade. I'm not bragging. I'm just still bitter about this. I'm like, he's waiting for like a D to come in the door, and then they would still make an A-. But if I know I'm gonna kick this class's ass, I am never taking the freaking B through D guy. Yes? Does that make sense? If I had a choice, he was the only one teaching the damn class. I'm like, shit. Because I found out nobody ever makes an A with this guy. I'm like, all right, whatever. Yeah, so it depends. If I'm like, oh shit, I don't know, this is weird. I don't know this stuff, you know. I'm gonna take the B through D, just to make sure I pass this thing, right? Which again, I'm not advocating for, but I understand, right? Anyway, so knowing the average they gave was a C by itself was not enough to determine a good way forward. I needed to know the spread of the data. So let me give you an example. Very often, the most common, so if I give a quiz, the average could be a lot of different things. And I'd say over the lifetime of my teaching, the average quiz average would be roughly a 75. Okay. Then I also calculate this number that represents how spread out the data is. So, normally I get about a 14. Right now you guys are all like, I don't know what the shit that means, dude. So here's the thing. We're going to end the class today, not now, hold on, just talking about the concept, and then the first thing we're going to do next time is get into the idea. What should spread mean? So for example, what's the average of this data here? You know what the average is real quick? Anytime you have symmetric data, the median is the same as the mean. So it's 3. But if you add them all up, you get 3, 6, 10, 15 divided by 5 is 3. Is that cool? Good. Okay. What's the average of this data here?
Also 3.
Also 3. 11. The way we define spread, since the first number we're always curious about is the middle, and the thing that we use the most for the middle is mean. Spread should then be how far do my data points get away from that average, on average, right? So which set of data gets further away from its mean more often?
The second.
You guys agree? So I think about it like this. This is home. Which kids got further away from home, right? These guys. So whatever this spread number is should be bigger for this than it is for this. You guys see that?
Yeah.
I like it. Now this is a very small set of data. It's very kind of visually immediately obvious. Big old sets of data are not immediately obvious. So if I give a quiz, the normal spread is about 14, meaning on average, people got 14 away from 75, 14 away from the middle. You guys with me? Some people scored really close. Some people scored really far away. It averages out to about 14 away. Does that make sense by itself? So all this spread number is how far away from the middle do all the data points get on average. So some of them might have been 30 away, yes? But some of them were really close, and it averages out to about 14. If I give a quiz, and the standard in the spread, sorry, I almost used the real word, and the spread comes out to be 20, what does that mean? So the normal spread is 14. That's about the normal kind of spread I expect. If I give a quiz and the spread is 20.
Yeah, very high and very low.
Yes, most likely there were really extreme kind of values, right? So maybe a lot of people made like 70s, and then like 5 people made 15 or something, 16 or something, and that just really made the spread really wide. Are you with me? So if I get a really big spread, I get worried. But also, what if I give a quiz and the spread number is 5?
Everyone did very similar.
Yes, which is also concerning to a teacher. Because what most often happens is that means everybody missed a few of the same questions, which means nobody understood those things. That's the most likely thing for that. You guys kind of with me? So whenever I give a quiz or a test, I will give you the average and I will give you the spread, just so you kind of know. And we'll talk about how you can use those numbers to tell kind of like where you fell relative to everybody else. Okay, ooh, that's exciting, Jeff. Thank you so much. All right, so, all right, I think that's probably enough for today. I get a sense that we're sort of at the end of our ability to handle me and what I'm saying. So, look for the videos if you want to see them. Don't forget tomorrow is our first quiz. And what I normally do is the quizzes start maybe about 10 minutes after class starts, just to give time for questions and so forth. Yeah.
And those are quizzes, like only a portion of class, not the whole